Section 9.5 Impedance and Admittance. In this section, we're going to learn two important concepts. The first one is impedance. Normally, we use the capital letter Z to represent the impedance. The impedance Z of a circuit is the ratio of the phase voltage V to the phasor current I, measured in ohms. We use the Greek letter omega to represent ohms. And you can find the property of the impedance is very similar to the resistance. And we can write Z like this. Z equals phasor V multiplied by phasor I. And you should know both of the voltage V and the current I are complex number. So Z will be a complex number, which means it has a real part and an imaginary part. The real part is R and the imaginary part is X. And we already know R is the resistance, and now we will call the X as the reactance. If the reactance X is positive, that means there is an inductor inside. However, if the reactance X is negative, that means there is a capacitor inside. The admittance Y is the reciprocal of the impedance, measured in Siemens. We use the capital letter S for it. Y equals the reciprocal of Z equals phasor I over phasor V equals G plus JB, where G is the real part of the admittance, while B is the imaginary part of the admittance. And you can find the impedance and the admittance for the element resistor, inductor, and capacitor. For the resistor, the impedance equals R, and the admittance equals the reciprocal of R. For the inductor, the impedance equals J omega L, and the admittance equals the reciprocal of J omega L. For capacitor, the impedance equals 1 over J omega C, while the admittance Y equals J omega C. And now you should know the impedance of inductor and capacitor is a function of the angular frequency omega. So if the angle frequency is different, the impedance is quite different. For example, for inductor, if omega equals 0, that means it is a direct current circuit, then they will be 0. That means there is no impedance at all. So inductance is short circuit at DC. While if the omega is approaching infinity, then they will be approaching infinity as well. So the inductor is open circuit at high frequencies. For the capacitor, because Z equals 1 over J omega C, so the greater the omega is, the less the impedance is. When omega equals 0, which means direct current, Z is approaching infinity, which means the capacitor is open circuit as DC. However, when omega is approaching infinity, Z will be 0, which means the capacitor is short circuit at high frequencies. This is the end of this section.